Hello everyone, welcome back to Code Management. In the previous episode, we learned what system design is and why software architecture plays a crucial role in building the scalable applications. So today we are going to discuss one of the most important concepts in every system design interview, that is functional and non-functional requirements. So, many candidates immediately start drawing architecture diagrams during interviews, but experienced software architects always begin by gathering the requirements. So, in today's session, we will understand the difference between functional and non-functional requirements. So, learn why they are important, explore the real world examples, and discuss how companies like Amazon, Netflix, and WhatsApp define their system requirements. So let's begin. So before starting, let's understand today's roadmap. So we will begin by learning what requirements actually are and why every software project starts with them. Then we will study functional requirements followed by non-functional requirements. And after that, we will discuss important quality attributes like scalability, availability, reliability, performance, security. So we will also analyze real world examples from Amazon, WhatsApp, Netflix, and finally, we will cover interview tips, common mistakes, and summarize everything. So by the end of this video, you will know how software architects think before writing a single line of code. So, what are requirements? So, let's begin with the most basic question. What are requirements? So, requirements describe what a software system is expected to achieve and how well it should perform. So, think of requirements as the blueprint of any project. So, imagine a customer approaches a software company and says, I need an online shopping application. So that statement alone is not enough. The software team needs to understand several details like can users register? Can users search products? Should payments be supported? How many users will access the application simultaneously? How first should the search will work? And without answering these questions, developers cannot design the systems properly. And that's why requirement gathering is always the first and important step in system design. Now we will know why requirement gathering. So many software failures happen not because like developers write bad code, but because the wrong requirements were collected. So imagine building a hospital management system. The client wanted appointment booking, patient history, and online payment as well. But the development team forgot to ask whether doctors should be able to access patient records remotely. Now, after deployment, adding this feature becomes expensive. Proper requirement gathering saves time, money, effort. So it also helps architects choose the right database, right infrastructure, the caching strategy, and scaling approach. So always remember a well designed system starts with well understood requirements. So now let's discuss about functional requirements. So functional requirements define what the system should do. So these are the features that users directly interact with. For an e-commerce application, functional requirements include user registration, user login, search products, add items to the cart, place orders, online payments, order tracking, wish list, notifications. So each of these represents a business function. So if a feature doesn't exist, users immediately notice it. So that's why functional requirement basically define the capabilities of the applications. And what is the functional workflow basically? So There is basically some simple workflow should be there. Imagine just you are shopping on Amazon. So the first thing what you will do, the first thing is simply you do is login. Next, you will search for a product. You add the product to your cart. Proceed to checkout. Right? We do those things. So for those cases, we need to mental proper things. And we are going to give you one example with Amazon case study. So whatever steps I have told you, like when you suppose shopping on Amazon, the first thing you do, login. After that, you will search the product, right? And you add the product to your cart. You proceed to checkout. You do the payment. You receive order confirmation. So each step is a functional requirement, and if any one of this feature is missing, the shopping experience become incomplete. So this workflow helps architects understand how different services communicate with each other. So just let's analyze the Amazon. So Amazon has numerous functional requirements. Users can register, they can browse the products, search the products, read the reviews, add products to wish list, add products to shopping cart, complete the payments, track the deliveries. So these define what Amazon offers. However, features alone are not enough. So imagine searching for a product and receiving the results after 30 seconds. So even though the search feature exists, user won't be happy. So that's where non-functional requirements become important. And that's why I have given you the Amazon case study first, and then I will talk about the non-functional requirements. So now let's move to these non-functional requirements. So these define how well the system performs. Instead of asking what features should we build, we ask how first should those features work? How secure should they be? How many users should the application support? Like API response time under 200 milliseconds, 99.99% uptime. So support for 1 million concurrent users, encrypted communication, automatic failure recovery. So these requirements determine the overall quality of the software. So first of all, the performance. The performance measures how efficiently the system responds. So there are three important terms for performance. One is latency, one is throughput, one is response time. So latency means this is the time required to process a single request. Response time is the total time users wait before receiving a response, and throughput is the total number of requests processed per second. So there is a difference between latency and throughput. I will discuss in another lecture about the latency and throughput. What are the differences between those? Okay, but in a nutshell, you just need to know like latency is the time required to process a single request. To process a single request, how much time it is required actually. And throughput is the total number of requests processed per second. Okay, so throughput is all about the total number of requests, and latency is the for a single request how much time it is being required. Okay, next is scalability. So scalability refers to the ability of a system to handle increasing traffic without any degrading performance. So imagine launching a startup. So initially you have only 100 users, but after 6 months you have 10,000 users. Later your applications become viral and now serves 1 million users. So if your architecture cannot scale, the application crashes. So scalable systems use techniques like horizontal scaling, load balancing, caching, distributed databases. Okay, so this is one of the most important non-functional requirements. So there is all about horizontal and vertical scaling. So horizontal means when we will increase the resources. Suppose now I have one CPU. In future, I will buy more 3 CPUs. So total 4 CPUs. In that way, horizontal. But vertical is like memory type. Like suppose I am using a phone with 120 GB memory. But after few months, I will buy for 256 GB memory. So that is one example of vertical scaling. Next is availability. So availability tells us how often the system remains operational. So companies usually express availability using percentages like 99%, 99.99%, 99.99999%. So higher availability means lower downtime. Like banking systems, healthcare systems, and payment gateways require extremely high availability because downtime directly affects the customers and business revenue. So architects achieve availability using redundancy, replication, failover mechanism, and load balancers. Right? Now reliability. So reliability means the system should consistently produce correct results. So suppose you transfer 10,000 using a banking application. The amount should never disappear. Either the transaction succeeds completely or it fails safely. Incorrect results are unacceptable. So reliable systems use transactions, data validations, backups, monitoring, fault tolerance to ensure consistency. Next is security. Security is another major non-functional requirement, and applications handle sensitive user informations like passwords, bank details, personal data. And to protect this information, systems implement authentication, authorization, encryption, uh, HTTPS, like secure HTTP, firewalls. There will be like role-based access control, input validation, secure APIs. So a secure system builds user trust and protects against cyber attacks. Next is maintainability. So software constantly evolves. Now, like new features are added, bugs are fixed, libraries are upgraded. Therefore, system should be easy to maintain. So good maintainability comes from clean architecture, modular code base, proper documentation, automated testing, coding standards. So maintainable software reduces long-term development cost. So if you will compare, like let's compare both concepts, like functional requirements answer what should the system do, like include login, search, payments, notifications, and non-functional like how well should the system perform, like include first response, high availability, security, scalability. So useful interview trick is like functional equals features and non-functional will be like quality. So remember this line because interviewers frequently ask this question about functional, non-functional, like that. So if like Amazon case study, WhatsApp case study, and Netflix case study, we will actually discuss now. So for Amazon, like functional requirements include like searching the products, placing orders, making some payments. Okay, these are the features. Those are the functional requirements. Like if you want to search some products, if you will place some order, and if you will make the payments. And non-functional will be like supporting millions of users, secure the transaction, and first product searches. Okay. Next is WhatsApp case study. So their functional requirements will be like sending messages, voice calls, creating groups. And non-functional will be like real-time message delivery, low latency, high availability, end-to-end encryption. Those will be like WhatsApp case study, functional and non-functional. For Netflix, like for functional, it will be like searching movies, streaming the videos, creating watch lists. And non-functional will be like requirements include 4K streaming, global content delivery network support, minimal buffering. So notice that every successful product has both the functional and non-functional requirements. So requirement gathering flow. So professional architects follow a structured approach. First, understand the business problem. Next, ask clarifying questions. Identify functional requirements. Then identify non-functional requirements. Prioritize them based on the business needs. Finally, validate everything with stakeholders. Only after completing these steps do like architects basically begin drawing the system architecture. So during interviews, never jump directly into designing the system. Instead, ask questions like how many daily active users, expected traffic, peak request per second, data retention period, security requirements, availability target, budget constraints. So interviewers appreciate those candidates who basically gather the requirements before proposing the architecture. Okay. So let's discuss the mistakes candidates often make. So, like ignoring the non-functional requirements, assuming requirements without asking questions, over engineering the simple systems, designing before understanding the business problem, not discussing the trade-offs. So, if you will avoid these mistakes, then you will immediately stand out and in any system design interviews. So let's summarize today's lesson. Like requirements are the foundation of every software system. Functional requirements define what the system should do. Non-functional requirements define like how well the system should perform, and both are equally important because a feature-rich application but without good performance, without scalability or security, still delivers a poor user experience. So always begin every system design discussion by gathering requirements before thinking about architecture. So in the next episode we will explore high level design versus low level design. So we will learn what each design level focuses on, when to use them, how they are used in software projects, and how interviewers evaluate HLD and LLD separately. So if you found this video helpful, don't forget to like the video, subscribe to Code Management, and share it with your friends preparing for system design interviews. Thank you for watching, and I will see you in the next episode.